Hey, welcome back. I changed my mind. It is worth checking, only because I think it's right. If we do x plus y plus z, or x plus y plus 4z, we have 95 plus 11, so 106, plus 4 times negative 15, so minus 60. So we have, what was it? 106 minus 60, which is 46 on the numerator, divided by 46. So we have 1, which is the right-hand side of our first equation in our system of linear equations. And we can check the other two if you want. But anyways, it gives me some confidence that all these determinants were right. Whatever the case, compare this to the row reduction process. You're going to get fractions. It's not going to be very friendly. Whereas here, the fraction step just happens at the end. Oh, and we already did this one. So this was done back here. Already did that. Okay, let's look at a example of an exam style question. Because this much work doesn't make sense for a multiple choice question. Doesn't really seem fair to do all this work and get 1 mark out of it. Or even to just do determinant of A divided by, or determinant of A2 divided by determinant of A to get the y value. Maybe that's okay, maybe that's not as bad. But here's a better example for how this concept could be tested. We're asked to find the value of y in the following system of linear equations. So we get ax plus by plus cz is equal to k, dx plus ey plus fz is equal to m, gx plus hy plus iz is equal to n. And we're told that the determinant of the coefficient matrix, so this has a coefficient matrix A, ABC, DEF, GHI. This says that the determinant of A is equal to 12. Now it gives us 3 other determinants. The first one, this matrix here, notice that this is the matrix with column 1 replaced by B. I got to identify what B is equal to. B is equal to the right-hand side, K, M, N. So this is A1. This is the replacement matrix A1. So it says determinant of A1 is equal to 120. This next one, ADG going down the first column, that's the first column of A. KMN, well, that's your B. And CFI, that's your third column of the original matrix. So this is replacement matrix A2. And the third one, look at that one. The first 2 columns are the first 2 columns of the coefficient matrix, and then the third column is the right-hand side. So this is A3. So that we have determinant of A2 is equal to 24, and then the determinant of A3 is equal to negative 12. We want the value of y inside the system of linear equations. So y is equal to the determinant of A2 divided by the determinant of A, which is 24 divided by 12, which is 2. That's right. That's it. That's our answer. So all the work is done for us. All the determinants are calculated. We just have to know that this is a Cramer's rule question to identify that this is not an inverse question. It's a Cramer's rule question. All the ingredients we need to solve the problem with Cramer's rule they're all present. We did not need to use A1. We didn't need to use A3. We would have if the question asked for X and Z, but it only asked for Y, so this is all we need to do. Okay, here's another one. Same idea, kind of, It asks instead for the determinant of the coefficient matrix. If the solution x, y, z is equal to 5, 2, negative 1, and the determinants of these replacement matrices, the same matrices we had in the last example, are given by these numbers. So I'm going to write down this first. Well, let's write down A. The coefficient matrix is A, D, G, B, E, H, C, F, I, and the matrix B is equal to K, M, N, and then we can recognize that the first determinant that's given, that's the determinant of A1, is equal to 50. The second one says the determinant of A2 is equal to 20. And then the third one says that the determinant of A3 is equal to negative 10. And we're told that x is equal to 5, y is equal to 2, and z is equal to negative 1. So let's find what the determinant of A is. We need to find determinant of A. How are we going to do this? Because we're used to saying that x equals the determinant of A1 divided by the determinant of A. We're not asked to find it for x, we were given x. We were given the determinant of A1 and we were not given the determinant of A. So what do we do? Well, I'm going to write down the formula again. Cramer's rule. Oh, and I should have written that down over here. By Cramer's rule. By Cramer's rule. By Cramer's rule, we have the following, that x equals the determinant of A1 divided by the determinant of A. So I'm going to put in our data. We are told that x is equal to 5. Determinant of A1 is equal to 50 divided by determinant of A is unknown. Next, I'm going to cross multiply. Multiply both sides by determinant of A. So 5 times the determinant of A is equal to 50. Then divide both sides by 5. Determinant of A is equal to 50 divided by 5 is equal to 10. That's it. So we're subbing in our data, and then we cross multiplied. And then divide both sides by 5. Why did I check x? So we could also check confirm, or can also check y or z if we want. So we have y equals determinant of A2, 20, divided by determinant of A. So 20 over determinant of A. So that means the y value is 2 is equal to 20 over determinant of A. And that means determinant of A is 10. Using the same process, cross multiply, so 2 times determinant of A is equal to 20, divide both sides by 2. Then we can do the next one. Z is equal to negative 10 divided by determinant of A. So Z, it says, is negative 1. Negative 1 is equal to negative 10 divided by determinant of A. And that means the determinant of A must be 10. So they'll all say the same thing as long as the question was built consistently. All right, and that's it for that topic for the first part of section 4.3. We'll continue in the next video.